Okay, so I've been asked to look at completing the square when the coefficient is above 1 for the x squared value. If you look at this question, the x squared value is a 2, so 2x squared. It does add an extra level of difficulty, so and there's not as many practice questions on this because you just don't see them quite as often as just x squared. So how we deal with this is we have to almost take the 2 out first. So I always use a square bracket to do this. So if I divide the whole thing by 2, I'm kind of then going to be left with x squared, then plus 8x, because I've just divided the 16 by 2, and then 35 over 2. You can just leave it as 35 over 2. It doesn't go exact, so I like just to leave it as a fraction for now. And what I've done is I've created a new, inside the bracket is you've got the 2 there, and it's kind of separate from this bit here. And then what we do, we just deal with this bit out inside the bracket as we are normally completing the square. So once we've taken that 2 out, we just deal with this and keep this 2 on the outside for now. So if I was to complete the square, if this was my thing, I would half the number in the middle. It's not 8x, it's 4x now. It's 4 now, sorry. So hopefully, so what that would do, hopefully you know about completing the square, but if I was to expand this out, you would get x squared plus 8x plus 16, because that basically means x plus 4 times itself. So we're kind of happy with the x squared plus 8x part here, the first couple of bits, but the 16 we need to get rid of. So we just minus 16, and then we've that means we've dealt with x squared plus 8x, and then we just add 35 over 2. Now we've got this 2 obviously on the outside, so what we do, we just have a put the 2 there, and we've kind of dealt with this bracket here, we've dealt with here, and now what we have to do is multiply everything that's not inside this bracket by the 2. You can kind of deal with this bit first if you want to, it might be easier. So minus 16 plus 35 over 2. So again, there's more than one way of doing this really. You can skip steps if you don't feel like you need to do this. So 16 over 2, I like the denominator is the same. So that's 32 is the same as 32 over 2 plus 35 over 2. Okay, and then we just go up here, 2 x plus 4 squared, and we get minus 32 over 2 plus 35 over 2, so that's a positive 3 over 2. And then, so that's made that much neater now. And then with this 2 outside here, you can keep it, you don't need to worry about multiplying the bracket here, but you do need to times it out here, and that gets rid of this bracket then here. So 2 times 3 over 2 is 6 over 2. Find this bit here. So I'm literally just timesing the 2 by whatever's over here, and then just leaving it in the front of this, which is absolutely fine. So 6 over 2 is actually 3. So I'm just going to add 3. And now this here is actually, if you look at the format they want it in A, which is our 2 value, x plus b, x plus 4 squared, plus c, and our c value is the 3. So it's now in completed squared format. Okay. Now, straight from that, there's the question just below. Hence or otherwise, write down the coordinates of the turning point of the graph. and it just gives you the same. Double checking. Yep, it just gives you the same one. So if you look directly at this question here, the x coordinate you get from this part here, and the y coordinate you get from this part here. So all we need to do is think, well, what do we actually, then it's thinking about is it positive, is it negative? Well, the x value, it's similar to when you find the coordinates where you pass the x-axis. It's the opposite of what you would expect, or what is inside the bracket. So therefore, the x value will be -4, and the y value will just be whatever this is here. It will just be +3. And again, there's links to when you have straight line graphs, it's always this constant value that's the y-intercept. It's kind of similar to how it works here. And you're just basically plugging it out of here. And you don't need to concern yourself with this 2 in front, as long as it's in this format and that 2 is already multiplied out that bit. That's absolutely fine. You just purely read off these 2 bits to find your turning point, minimum or maximum. As it's a positive x squared, it would be a minimum point rather than a maximum. Okay, so I hope that's helped. That is a slightly more challenging when you're completing the square. That is slightly more challenging when there's a coefficient in front of the x squared. But hopefully that's helped to give you an example of what it could look like and how you would solve that. Okay, thanks for listening.